Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about proofs. This is going to be an introduction to proofs video, and we're going to talk through one algebraic proof and 3 geometric proofs. Proofs are really interesting because in math, a lot of times we do things just because it's the next step, or, well, the formula says to do this. But proofs really force us to figure out why are we doing a particular step? What's the reasoning behind a step that we're doing? Over here on the right, you'll notice that I've listed out a few different common reasons for proofs that we're going to see pop up in this video. This is by no means all the reasons we're going to use. We're going to use lots of different reasons, but these are ones I really wanted to point out because we see them a lot. I'm not going to go through all of them to start. We're just going to kind of, as we come to them, I'll point them out. So this is a basic proofs table. Now I have this one numbered already. A lot of times in your math classes, they won't have them numbered already. Sometimes they will, but sometimes you have to create your own table. Proofs are very subjective. There's no one right way to do something, typically. There's going to be lots of different paths that you can take and get the same answer. I've laid them out here just kind of for simplicity, but just keep that in mind that someone else may have a different method for solving something or a different order that they use, and that could be completely right as well. So for algebraic proofs specifically, what's really important is we don't want to put any work inside of our table. Our table is just for our statements and our reasons. It is not for any work. So any work that we need to do, we are going to show over here on the side. You'll notice that the first thing that we're told is we are given this statement. Now, I love our given statements because they're what I like to think of as free points in the proof. Our first statement will always be what we're given. In this case, we were given 3x plus 10 equals 8x minus 15. So I'm going to write that statement. What is my reason of knowing that's true? Well, it was given. So my reason is just given. A lot of times we'll have more than one given statement, and we'll see that in a few of our next problems. In this example, we only had one given. Now, our next part that we can go ahead and fill into our table is our prove statement. We're given this algebraic equation, and we want to prove that x equals 5. So by the end of this table, right here, our final statement should be x equals 5. Now we can't just put proven. We're going to have a reason here, and so we can't fill it out yet because we don't know what that reason is. But these 3 would be automatic points that you would want to make sure you get on a test or quiz. To fill in the rest of this table, what we want to do is bring this equation over here on the side. I'm just going to rewrite it on the side here. 3x plus 10 equals 8x minus 15. And we're going to solve this equation here on the side, and we'll fill in the table as we go until we get to our answer that x equals 5. I like to get my x's together first, and I specifically like to move a smaller x value to the larger x value. I'm going to do that through subtraction. And the reason I'm doing it by subtraction is because this is a positive 3x, and I want to move it to the right. So I need to subtract 3x. And 3x minus 3x is 0, cancels. But what I do to one side, I have to do to the other. So if I'm going to subtract 3x over here, I've got to do it over here as well, combining it with that 8x. So let's bring down what we have at this point. We've got our 10. We've got our equals. 8x minus 3x, that would leave us with 5x. And then let's bring down our minus 15. So what I'm going to do is now bring this statement, after I've subtracted 3x from both sides, this statement is my next step. So 10 equals 5x minus 15. Now we have to think, what was our reason? How did we get from here to here? How did we jump from here to here? Well, we subtracted, right? We subtracted 3x. So our reason here is something called the subtraction property of equality. Now, I'm going to shorthand that because that's a lot to write here. I could totally write it out, and that's fine. Some teachers may require that you write it out 100%. So it's the subtraction, and then I'm just going to write POE, property of equality. So let's continue our steps. Jumping back over to our problem with the work. I've gotten my x's together. Now I want to get my constants together. Since I've already moved the x over to the right, I'm going to move my constant over to the left. That means this is a minus 15. I'm going to add 15. So that it cancels on that side. Negative 15 plus 15 is 0. But if I'm going to add 15 here, I've got to do it to the other side as well. Now 10 plus 15 is 25. And then bringing down what we have left, we have equals 5x. So now that we've done the work for our next step, let's bring the result over here into our table. Now what did we use to go from step 2 to step 3? Well, looking back at our work, we added. So for this one, we used the addition property of equality. And again, I'm just going to shorthand property of equality as POE. Looking at this problem now, this is 5 times x. We're so close to having x alone, but it's not quite isolated yet. We need to get rid of the 5. So how do we undo multiplication? We use division, and we divide by what we want to get rid of, in this case 5. So if I divide by 5 on this side, I've got to do it on this side as well. And 25 divided by 5 is 5. So we've got 5 equals x. So at this point for step 4, let's bring over, we've got 5 equals x. Now, what was the reason? How did we go from step 3 to step 4? Looking back at our work, we divided, right? So for here, we're going to use the division property of equality. Looking at our next statement, because normally in math we kind of stop here and we say, oh, there's our answer, we circle it and we're done. But we're not quite done with our proofs table yet, because notice what's happening between 5 equals x and x equals 5. These two say the same thing, but they're flipped, right? That is going to be called the symmetric property. Notice the symmetric property is if A equals B, then B equals A. And it just shows that we can say 5 equals x, or we can say x equals 5, and they are equivalent to each other. For our reasoning of how we can jump from 4 to 5 is the symmetric property. All right, and there is our proof. For this example, we're going to be doing a geometric proof. So for this one specifically, we're not going to be doing work on the side. We're going to be marking maybe sides that we know are congruent or angles that we know are congruent actually on the picture to help us complete this table. There are 2 of my videos I'm going to recommend as prerequisites to geometric proofs. The first video is called Parallel Lines and Angle Relationships. We need to be able to quickly recognize the different relationships between various angles. The second video is called Triangle Congruence. We need to know all the different ways to prove if 2 triangles are congruent to each other. You will want to feel confident in both of these skills before completing geometric proofs. The first thing that we always do in a proof is going to be to look at the givens. They've given us a few given statements, and in this case they've given us 2. They said line MN, okay, so let's think about this, line MN is congruent to line NO. NO. So what I like to do is go ahead, as we fill in our statements, let's mark that on the picture because that'll help us try to figure out where to go after we finish our givens. So MN is congruent to, and we show that with a little tick mark. MN is congruent to NO. And when I look at this picture, what that means is this length is the same as this length. So let's go ahead and fill in that statement and our reason given. Okay, now we have a semicolon, which is showing us that this is a separate given. So we have, like I said, two givens in this problem. Line LN is congruent to line NP. LN is congruent to NP. So this time we're not going to use a single tick mark, we're going to use a double tick mark because the single is already taken. Let's go ahead and fill in our table with that information. Okay, so we've completed our givens. We can go ahead and put our proof statement right here at the end because that should be our last final statement, that triangle LMN is congruent to triangle PON. So that's kind of like our end goal with this table, is to get to that point. By just filling in our givens and our proof statement, we've completed over half the table. We only have 3 spaces that we have to fill in. When I look at this picture, I definitely recognize that we have vertical angles here and here. And I recognize that because these are 2 angles that form an X. And anytime we see 2 angles that form an X, that means they're vertical angles and the opposite angles are congruent to each other. I'm going to go ahead and put that statement in here. So angle LNM is congruent to angle PON. And the reason I know that is because vertical angles are congruent. And notice I kind of shorthanded there. I used the congruent symbol instead of writing out congruent. Again, that's just personal preference. Just ask your instructor what they prefer. So now we're at a point where we're able to prove that triangle LMN is congruent to triangle PON. And the reason we're able to say these triangles are congruent, and again, this goes back to our triangle congruency video, is through side, angle, side. And we can write that out, or we could just shorthand side, angle, side. In this next example, we're given the statement that line QR, which is right here, is congruent to line RS, which is right here. So let's go ahead and mark that on our picture and add it to our statement and reason line. We are given a second given statement here as well, that line TR, which is the center line right here, bisects angle QRS. So QRS would be right here, QRS. This line bisects this angle. So let's add that to our statement and then with our reason being given. So now let's add our prove statement. It says line QT is congruent to line ST. So we'll add that right here. That's our end goal. Okay, now that we've gotten all the information they gave us into the table, let's try to think of where we can go from here. So my mind immediately goes to this statement that TR bisects angle QRS. to understand what a bisector is, an angle bisector, I've included this definition over here. So an angle bisector divides an angle into two congruent angles. So what that means is when you have a line that is bisecting an angle, it cuts the angle into two equal parts. And what that means is if we know that TR is an angle bisector, then we know that angle QRT and SRT are going to be equal to each other. So if this one is 30 degrees, then we know that this one is also 30 degrees. So let's go ahead and write those markings that I just created there. And then for our reason that we know these two angles are congruent is it's just the definition of an angle bisector. Now I'm going to shorthand, I'm just going to write DEF for definition. What else do we notice about this picture? Now there's one thing that definitely sticks out to me, and it's this center line right here. This center line is really two lines because we've got a triangle here and a triangle here. If we were to separate these triangles, they would each have this center line, right? It's just overlapping. And when that happens, that's something we call the reflexive property, which I've noted over here. Our reflexive property states, and I just used AB as an example just to show. So line AB is congruent to line AB. The reflexive property is when something is congruent to itself. And I always remember this because I think reflexive sounds kind of like reflective, like as if you were looking in a mirror, you'd see a reflection. So I don't know, that's how I remember the reflexive property. But anytime we have a line that's really two overlapping lines, we can say that those two lines are congruent to each other. And so I'm using two tick marks just because my single tick mark was already taken. So let's go ahead and make that statement. Line RT is congruent to line RT. And the reason we can say those two overlapping lines are congruent to each other is because of the reflexive property. Okay, now looking back at our picture, I notice that these two triangles are congruent to each other. We have side, angle, side. And see on this one, we also have the corresponding side, angle, side. So side, angle, side is a way to prove that two triangles are congruent to each other. So let's state that. We've got triangle QRT is congruent to triangle SRT. And the reason why we know these two triangles are congruent to each other is side, angle, side. It's totally fine to just shorthand SAS. When I look at my proof statement, they're asking us to prove that line QT is congruent to line ST. So QT is congruent to ST. So let's go ahead and mark that on our picture that these two are congruent. And how can we say that those two are congruent? It's because of this down here, CPCTC. And what that stands for is corresponding parts of congruent triangles are congruent. Now I know that's kind of a mouthful, but what it's saying is that if you've proved that this triangle is congruent to this triangle, like we did on line 5, then we can say any corresponding parts of those two triangles would also be congruent to each other. So we can say that this line and this line are congruent. Even though we didn't know anything about those lines before, now that we know these two are congruent, we can say those two lines are congruent. In the same way that we could say angle Q is now congruent to angle S, right? Now, they didn't ask us to do that, but we could say that at this point, once we know the two triangles are congruent to each other. Our reasoning for knowing those two sides are congruent is CPCTC. Corresponding parts of congruent triangles are congruent. Let's look at one last example together. So for this one, it says given line AB is congruent to line CD. So let's mark that on the picture. Line AB is congruent to line CD. And let's add it to our statement with our reason being given. Our next given statement says E is the midpoint of line BD and of line AC. So let's add that to our statement with our reason being given. Lastly, let's add our prove statement. So we are trying to prove that angle A is congruent to angle C. So now, looking at these given statements, especially the second one, E is the midpoint of line BD and line AC. So let's think about, what does a midpoint actually mean? And I've included a definition over here for us. So a midpoint is a point equidistant from two endpoints. So equidistant just means that it's equal distance. And so if we have two endpoints, for starters, line BD, so this line right here, BD, if E is our midpoint, then what that means is that line BE, this section right here, will be congruent to line DE, this section right here. So we can add that as a statement. For our reason, we can just list definition of a midpoint. And I'm going to shorthand definition to just DEF. So if E is also the midpoint of line AC, as our given statement told us, then we can say the same thing for line AC. We can say that AE would be congruent to line CE. Because E is the midpoint, it cuts that line perfectly in half. So let's add that as our next statement. Our reason will also be the definition of a midpoint. Now when I look at our two triangles now, I can tell that these two triangles are congruent. And I can tell that because they have side, side, side. And side, side, side is a way to prove congruency. So let's add that our two triangles are congruent. So triangle ABE is congruent to triangle CDE. And our reason being side, side, side. So now looking at our prove statement that angle A is congruent to angle C, let's mark that on the picture. Angle A is congruent to angle C. We can now say that's true using our CPCTC. Corresponding parts of congruent triangles are congruent. So once we've proved that these two triangles are congruent, we can say that every single corresponding part of those triangles are congruent, and specifically angle A and angle C are congruent to each other. Thanks for watching. This has been Miss Math Tutorials.